Hi everybody, Physics Ninja here. Today what I want to do is I want to do the derivation of the amortization formula. And basically it's this formula right here on the side. It's the amount of money you're going to pay per period. Now in my case, I recently bought a new pickup truck. And boy, do I love my pickup truck. But I borrowed some money from a bank and the bank charged me an interest rate. Based on that interest rate, they came up with a monthly payment, right? I'm going to pay the truck off over a 5-year period. That's 60 months. How did they determine the monthly payment that they would charge me? So we're going to go over this formula. And the reason I want to go over this formula is because when I bought my truck, the salesperson wasn't 100% truthful with me. And I didn't really trust them. So I said, you know what? I want to figure out how they calculate this number. So I'll go through that with you in all details. All right. Like with all my videos, if you like it, give it a thumbs up. Consider subscribing to my channel. Leave a comment down below and ask questions. I'll try to get back to you as quickly as possible. All right, let's get started. All right, like I said, I thought the salesperson was a little bit strange because we were kind of having conversations on the phone and he wouldn't tell me the interest rate that they were giving me, right? It was really hard for me to get this number from him, because I wanted to just shop for an interest rate by myself. So I contacted my bank. My bank was going to give me a loan for 3% interest rate. Okay, and that was great, I thought. He said he could beat that, but he wouldn't tell me the number. And then they eventually give me the number, and they send me to a link. They say, which payment do you want? The 60 months or the 72 months? And I said, I really want the 60-month payment plan. And then the number that comes up here was, what, $630.48 a month for this pickup truck, for me to borrow that money. And I have to make this payment for 60 months. Well, then I just really didn't trust the guy. How do you get this number? How do you calculate this number? So I looked online, right? Let's go see what kind of online calculators we can find. Okay, and if you go online and you look for amortization calculators, you can find a whole bunch, right? You just kind of put in the numbers, right? How much you want to borrow, what's the interest rate, the number of payments. And anyway, it'll print off a table, for example, or it'll just give you the number, right? And there's a whole series of these kind of online calculators. Now, a lot of them don't tell you which formula they're using, but whatever, you check 2 or 3, and if you get the same answer, it'll give you some confidence that they're doing the right thing. Now, the next thing you could do, which I dug a little bit deeper, is, well, how do they actually calculate that number, right? What is the formula they're using? There must be a mathematical expression for it. So then I started looking up car loan formulas, right? And they all kind of have this same look. Sometimes they're printed off a little bit differently, but they're kind of similar, right? They have the same variables. Sometimes, depending on the author, they might write it a little bit differently. But again, the formula is not that straightforward, right? It looks kind of rather complicated. And it's like, why is it so complicated? So let's go through the derivation as to how you actually arrive to this formula right here. And then let's test it out. Another thing I did just to check stuff out was I looked at Microsoft Excel. Microsoft Excel has a function called payment. It's PMT, and there's a few inputs that you have to give it, but it's pretty straightforward. First of all, they want to know the interest rate that we're going to have on the loan. So for me, it was 2.79. It's percentage. And they want to know the percentage per period. So in this case, it's per month. Okay, so you also divide that by 12. The total number of payments, again, that was 5 years. So 5 years gives me 60 months for the total number of payments. And how much money did I actually borrow? For me, it was $34,470. Okay, so I give it those 3 values. That's it, right? This you can kind of see right here, hopefully. And at the end, I'm stuck out with this number, $616.17. Well, that's a little bit odd because the guy's email sent me a link that was going to be $630.48. Well, which one is it? It's probably the 616, right? I think he was trying to get a free lunch once a month, right? Charging me an extra 14 bucks. I don't think so, buddy. All right, so anyway, I caught him in this little lie. He confessed it was a mistake. He didn't kind of say that he was trying to make $14 a month from me. But let's go through the derivation now, and we'll see how you get to this number, $616.17. All right, let's go. All right, so we're going to start with some basic definitions here just to define some variables. We have a P0. This is going to be my initial loan value, right? The principal value, right? And for my case, like I said, is $34,470. They are charging me an interest rate. Okay, so this is a number. In my case here, the dealer was able to get an interest rate of 2.79%. If I write that as a decimal, right, just divide that by 100. There you go. That's my interest rate. Now you also want to know the rate per month. Okay, so you basically just take this number, the 2.79%, and simply divide it by 12, right? This will be the rate per month that I am being charged to borrow some money. My goal now is really to calculate this value right here. What is going to be my monthly payment? This is going to be a fixed value, right, over the repayment of the loan. So let's go ahead, and this is really what I want to calculate. And another important quantity is clearly the number of payments, right? If I have a longer period of time, I'm going to have a smaller monthly payment, right? So you typically have 4, 5, 6 years, right? So for us, we're going to define this as little n, and for my case, I wanted 5 years to repay this truck. So 5 times 12 gives me 60 payments, right? Every month for 60 months, I have to make this truck payment. All right, so let's go ahead now and set up some of the math, and let's go back and see how do we actually evaluate this monthly payment. All right, so here are our definitions. And again, we're going to look at a few quantities here. We're always interested in how much money we start at the beginning of the month, what our payment is, right? And that's going to be fixed. How much the bank is going to charge us, and then what the ending balance after we make that payment. Okay, and then we got to do that for, 60 months. But let's just start with the first few, and you'll see kind of a pattern develop. So again, I'm kind of interested in how do you calculate this ending balance. Okay, so for this one here, I'm going to call it P1. This one here, I'll call it P2, P3, P4. All right, how much money do I owe after making that first payment? Okay, well, it always depends on where you start, right? So for the first month, well, I started out at P0, right? That was the initial value that I had. And guess what? I made a monthly payment. So I have to at least lower the amount that I owe by some value, right? And that monthly payment is M. However, they did charge me a little bit of money because I owed them some money. I owed them this amount of money, right? So the bank wants to make some money. So they charge me a little bit of interest rate, right? So I want to include that interest rate here. And that interest rate will be the amount of money that I owe them multiplied by this monthly rate here, which is simply the little r value. All right, now all we're going to do is, this is the formula. We're just going to rewrite it here. Let's factor out P0. This looks like a 1 plus little r term, and then minus the monthly payment. Okay, so that's it. This is going to be the ending balance for month number 1. Well, guess what we're going to do now? We're going to kind of repeat this process now for month number 2. What was my initial starting point? My initial starting point was the month number 1, right? And guess what? I made another monthly payment, right? If you make a monthly payment, you're going to lower the amount of money that you owe. However, you have to pay a little bit of interest, right? And the amount of interest that you get charged is this much, right? The amount of money that I owe multiplied by that rate. Again, now I could do the same type of math and simply factor this out, right? So let's go ahead and do that. So this will be P1, and now 1 plus R, again, minus M. Well, you can kind of see, hopefully you could see a pattern developing here. All right, let's do this one more time. For the third month, I'm going to start off owing them the principal at the second month, right? My ending balance becomes the starting balance for the next month. Minus the payment plus the amount of interest that I owe them. All right, again, factoring out the P2 term, 1 plus R minus M. All right, and anyway, we can now just go ahead and skip this last step and just simply write it out. This is simply going to be P3, now 1 plus little r, and then minus M. All right, we've actually done quite a bit of work right now. All right, let's have a look at our formulas. All right, here's our formula for the ending balance after month number 1. Here's the ending balance for month number 2, number 3, and number 4. And actually, we can keep going, right, all the way to 59 and 60. All right, so you can also see that from just kind of the trend over here, that whatever number you have, whatever month you're evaluating, this number here is always one lower than that one, right? So you could write kind of a general formula for like the n+1 month should be equal to the value that you started with, right? Which is the nth month. Again, 1 plus that monthly interest rate, and then minus our monthly payment, which is really what I want to calculate at the end. But this is kind of our recursive formula right here that allows you to calculate it for each month as long as you know the initial value that you started with, P0. All right, what we're going to do now is we're going to get things in a more useful form. So I'm going to actually start with our equation for P3 here. P3 is, here, let's just go ahead and write this, P2, 1 plus R minus M. To take this a little bit further, what I'm going to do now is instead of writing P2, well, I can actually substitute that and write it in terms of P1, right? Just using the equation just above it. All right, so this is our value for P2. And now I still have the 1 plus R term and minus M. Okay, now what I have to do now is, in order to kind of just not make any mistakes, let's carry that out. So now we have P3 in terms of P1. All right, you're going to have 1 plus R. However, look what happens over here. This becomes squared. And then look at the next term. You get minus M, okay, 1 plus R. And again, minus another M like this. All right, this is kind of getting interesting. Now, the last step I can do, for at least for P3, is I could also eliminate P1 using my first formula that I had. So let's do that. So here we're going to have P0, 1 plus R minus M. I'll put a square bracket around that one. That is our definition of P1. And then here I have 1 plus R squared minus M. 1 plus R minus M. Now this looks like it's really, really complicated, but it's not. You just got to be a little bit careful with the algebra. All right, now we're going to distribute this through. And now we're going to have an expression for P3 in terms of the initial loan value that I had. And this is what it looks like. It's 1 plus R. Oh, look at this term. It becomes cube. Okay. Now look at all the terms with M now, right? We're going to have minus M. I'm actually going to factor things out. I'm going to use a curly bracket now. If you think about all the terms now that are going to have an M in front, I'm going to have this term, 1 plus little r squared. What else? Plus 1 plus r to the 1, right? And really this last one, it's really just plus 1. Then I'm going to close the curly bracket right here. Well, this is kind of a really, really interesting formula to me. Okay, so we have P3 now written in terms of P0. Okay, and hopefully you can start seeing kind of what is going on here. So what we're going to try to do now is let's try to write the generic equation. Right? The goal will be to write what is the generic equation for the nth payment over here. Okay, the nth ending balance in terms of P0, not in terms of the month previous to it, but we want a function here in terms of P0. So let's see how we can do that using our expression here for P3 that we just derived. All right, first thing I want to do here is I'm going to rewrite this expression. As I rewrite it, I want to point out a couple things. Okay, this is always going to be my initial value, right? That's the principal. 1 plus R, and first thing I want you to notice here is that if this is the third month, this is also going to be the matching power, okay? This is 4, this is also going to be 4. Minus M is our monthly payment, open the bracket. The only thing I'm going to do here now is I'm going to switch the order. Let me put the number 1 first here. Let me put this one here second, 1 plus R. It's really to the power 1, plus 1 plus R raised to the power 2, and that's it, okay? The other thing I want you to notice here is that for this summation, right, I'm adding a bunch of terms here, is that it always terminates with an exponent that is 1 less than the one I'm trying to write out, okay? So imagine now you're trying to write an expression for the nth month. Based on the third month equation, this is what it would look like, right? It would be the P0, my initial principal, 1 plus the interest rate, raised to which power now? Well, you'd raise it to the nth power. Okay, minus M. All right, now this term here, you're going to have a whole bunch, right? If this is 10, I'm going to have a whole series of terms, right? I'm going to have this one. I'm going to have the next power, 1 plus r to the 1 plus 1 plus r to the 2, right? If this is 10, I have to go all the way to 9. I'm not going to write all those terms. I'll just use add plus. Now the last one I'm going to finish at is this one here, 1 plus r raised to which power now? It should be 1 less than whatever value this is. So this should be raised to the power n minus 1. All right, and that's it. Close the bracket. Now this term right here is simply a series, okay? If we go back to kind of high school math, we call this a geometric series. And the nice thing about geometric series is there is an analytical equation that allows us to write this term into a very compact form. So let's go work on this geometric series term to simplify our expression here for the ending balance after the nth month. All right, so to simplify this series, what we're going to do here is we're simply going to define it as x. Okay, let me go ahead and write it down. X is simply going to be 1 plus r plus 1 plus r squared plus all the way to the end, right? The last term here is going to be 1 plus r to the n minus 1. All right, so to solve for what x is, this is kind of a little trick. What you end up doing here is you multiply it by this guy, right? What if I multiply it by this term 1 plus r? What would this look like? Well, the first term, if you think about it, would be 1 plus r. That's it. The next term would be, well, 1 plus r, the same thing, except raised to a higher power because it's simply multiplying the same thing, right? So you can kind of see what's going to happen here. Now, what is going to be the last term? If I multiply 1 plus r to the nth minus 1 with 1 plus r, well, at the end, you're going to be left with this guy, right? 1 plus r to the nth power. That's it, right? And again, n is 1 bigger than this one. All right, in order to kind of solve now, the goal is always to solve for what x is. What we're going to end up doing here is taking the difference here, okay? So if you call this kind of equation 1 up here, call this equation 2, what you end up doing is doing 2 minus 1, okay? And you'll see what happens in this case. Right? If you do 2 minus 1, you can see there's a whole bunch of terms that are going to cross out, right? This one here is going to cross out with this one. This one's going to cross out with this one. This one's going to cross out with the other one over here. There won't be anything left over to cross this one out because it ends up being 1 power higher, but this one is also going to get crossed out. Okay, so let's go ahead and do that. And what does the left-hand side look like here? This is going to be 1 minus r multiplied by x minus x. Okay, this here has to be equal to, again, at the end, we're simply going to be left with this guy, 1 plus r to the nth power. And there is nothing to cancel out the 1, so you're still going to be left with minus 1 here at the end. All right, think about the left-hand side over here. Think about what we have here. We're going to have, if you distribute this x here, you're going to have x minus x, right? So actually, this guy is going to cancel out with this guy. So the entire left-hand side here boils down to simply little r multiplied by x. And that's it. This term here stays the same, right? 1 plus r to the nth power minus 1. All right, so my final expression now for x, just go ahead and write it right here. X is going to be 1 plus r to the n minus 1. All of this over little r. All right, that is the entire geometrical series. And what you can do now is, well, you can go back to my expression and eliminate this big mess because we know the value. The value is simply in this green box. Okay, so we're going to finish this off now, substitute the value for the geometrical series, and calculate what our monthly payment is. All right, what we're really interested in now is that when n is kind of at 60 payments, is that my ending balance right here, we really want this to eventually be equal to 0, right? That's the whole point. For which value of m is this payment eventually going to be 0? Okay, so this is what we have to solve for. So we're going to have 0 equals to, again, this whole right-hand side of this expression. Minus m 1 plus r to the nth power minus 1 over that monthly interest rate. Okay, my goal now is to solve for what is my monthly payment that is going to make this happen. Okay, so let's go ahead and now do some algebra. So if I bring this whole term on the other side, 1 plus r to the n minus 1 over little r, and then this whole term is left over, right? P0, 1 plus r to the nth power. All right, our last step now is simply solving for the monthly payment. Just bring this bracket on the other side. I'll write P0 first. It's multiplied by little r, then multiplied by this entire term, 1 plus r to the nth power, divided by, all right, and now this whole term, right? 1 plus r to the nth power minus 1. All right, so this is actually our final expression for our value. Now, guess what? So if I take my values for my particular case, remember my initial loan value was $34,470. Okay, what else? I had little r, which was my interest rate, 0.0279, right? 2.79%. But again, I want to divide that by 12. Okay. And what else goes in there? Oh, I also had my total number of payments. I had 5 years. This was 60 payments. Right? We have a nice closed form. It allows me to calculate what my monthly payment is. And my monthly payment for my loan, if you remember, was $616.17. All right, that is the formula. Right, that's the formula they use in all of those online calculators, and also the formula that's used in that Excel spreadsheet. All right, I'll go ahead now and show you a little bit of Python code that I wrote just to calculate the table, just so we can look at some of the values. All right, just want to show you just a bit of code here that I wrote using Python. Here's some of the initial conditions. We've got the initial loan size, $34,470. We have the interest rate, the monthly interest rate, and the total number of payments. The next line is the monthly payment. That's the equation I just derived, okay? Now, we have a loop here that goes over the 60 payments that I'm going to make, okay? And basically what I want to do is I want to calculate what the starting balance is and what the ending balance is for each one, okay? So for the first one, well, that's simply equal to P0, okay? For each additional one, if you remember the formula I had, it's kind of this guy right here. At any other one was, or if this was n plus 1, this was n1 plus r minus my monthly payment. Okay, that was kind of one of the equations that we saw. Now, the next thing I wanted to do is calculate the interest rate, or the amount of money that I pay in interest at every month. Okay, so that's simply the starting balance multiplied by little r. That's this line right here. The balance at the end is our equation right here that we have. And I also have an expression here just to calculate the total interest. So basically at every month, I simply add the new interest to some running total. Okay, and then I produce a table here with all of these values. Okay, so let's go ahead and look at the table, see what that looks like, see what the values look like. Okay, so these are some of the payments. This here goes over some of the first few here, going up to 25. I'll show you the bottom of the table in just a minute. Right, but we start here with payment 1. Again, that was our initial balance. Okay, this was our interest rate, and here's my monthly payment. So after making that payment, this is how much money I owe, right? You see this number here ends up being the starting balance for the second payment. One thing you can see is that the interest rate is not constant. Although the payment is constant, the interest rate always changes, right? I pay more interest at the beginning of the loan than I do at the end. Right, for the 25th payment, for example, look at how much interest I'm paying, just a little bit under $50. Still making the same monthly payment, but I'm paying less in interest. There's more going toward the principal, to lower the principal or the amount of money that I owe. Okay, if we keep going all the way to the 60th month, right, the last payment right here, at the ending balance here is going to be equal to 0, right? Basically, I'm paying very little interest on that last payment. All right, they get their money. The bank gets their money at the front end. They get very little at the back end. Okay, and again, always making the same monthly payment. Anyway, that's it for me, folks. Hopefully you found this kind of a useful derivation, and now you know where the formula comes from.